All right. So let's look at calculations based on chemical equations, please. There are some calculations we can make based on chemical equations. Number one, first, note. Note, please. The first thing to note, please, under this, please. Note. All equations must be properly balanced before any calculation is carried out. All equations must be properly balanced before any calculations must be carried out. When you do your test question, you see that in your test, they'll actually give you a balanced equation most times. But what if they don't give you a balanced equation? What if? Please, your first time, before you start solving, always check if the equation is balanced. If it's balanced, you can now start solving. If it's not balanced, first of all, balance it before you start solving. So what are these calculations that we can do based on chemical equations? Number one, number of moles of reactants and products. Please, the first kind of calculation we can do on chemical equations is the number of moles of reactants or products. I'll take a simple example. I'll explain this and we proceed, please. Example. Nitrogen combines with hydrogen to form ammonia. Nitrogen combines with hydrogen to form ammonia. How many moles of hydrogen? How many moles of hydrogen are required to react with? How many moles of hydrogen are required to react with 300 moles of nitrogen? How many moles of hydrogen are required to react with 300 moles of nitrogen? So look up, please. Look up. For questions of this manner, your first task is to write a balanced chemical equation. In your test, which we'll do shortly, you observe that to first of all give you the equation. But then, let's assume we're not given equation. So if I look at the side, nitrogen combines with hydrogen to form ammonia. My reactants are 2, nitrogen, hydrogen. My product is 1, ammonia. So, okay, on your own, please. But let me save time, since I'm recording. Nitrogen is what there? Not N, N2. Now, this is where people mix it up. At this point now, note the atomicity. Nitrogen is not N. Is what there? N2 is the atomic. Plus hydrogen, H2, to give you the said ammonia. Ammonia is NH3. Please note. So please note, nitrogen is the atomic. It's not N. It's N2. Is the atomic. So I'm having this. So I'm having this one here. So I'm having nitrogen combining with hydrogen to form ammonia. We said we cannot work on this except, first of all, we balance this. In balancing this, I'm seeing 2 of nitrogen. This is 1. I'll simply add 2 here. We add whole number coefficients. Of course, 2 times 1 is 2. 2 nitrogen here, 2 here is balanced. Hydrogen, I have just 2 here. For here, I have 2 times 3, that's 6 hydrogen. 6 here, 2 here, I'll simply add what there? 3. So it becomes 3 of hydrogen. At this point now, I have a balanced chemical equation. My first task when it comes to balancing chemical equation. What's next? The next task is to get what is called molar ratio. What's molar ratio? In a layman's term, molar ratio is simply the ratio of the coefficient of each of the reactants and product. That's all. In other words, for this case, molar ratio becomes coefficient here is 1, ratio is 2, coefficient here is 3, is 2, coefficient here is 2. So my molar ratio is 1 is to 3 is to 2. It's called a molar ratio. Listen and listen carefully. For every calculation that is involved in equations at your level, they will always, no matter the number of reactants and products, they will always give your focus to 2. To 2. Please check your question, please. Your question says nitrogen combines with hydrogen to form ammonia. Okay, so what? They said how many were there? They mentioned hydrogen. Are required to do what there? So observe that, first of all, they helped us to form our equation. And I said, no matter the number of products and reactants in the equation, they will always narrow your mind to 2. The 2 in this equation are what there? Hydrogen and nitrogen. How many moles of hydrogen are required to react with what there? 300 moles of what? Nitrogen. So it means in this case here, I'll simply narrow my focus to what? Hydrogen and nitrogen. All right, if you're here, take down this statement. If you're here, take down this statement, please. From the balanced equation of the reaction, so see here, 1 mole of nitrogen is needed to react with 3 moles of hydrogen. You can see that. From the balanced equation of the reaction, 1 mole of nitrogen is needed to react with 3 moles of hydrogen. Full stop. Let the amount of moles, they ask you, how many moles of hydrogen? Let's call it X, unknown. All right. Let the amount of moles of hydrogen, required to react with 300 moles of nitrogen be X. So we don't know, let's call it X. Let the amount of moles of hydrogen required to react with 300 moles of nitrogen be X. Hence, so if you're done, look up, please. Hence, so next up, I said in all of these, they'll focus on 2, which in this case was nitrogen and hydrogen. So please, you do this. From balanced equation of reaction, 1 mole of nitrogen will react with 3 moles of hydrogen. We said, let the number of moles of hydrogen that will react with how many nitrogen there? 300. With 300. We don't know how many of this will react with 300. We call it X. Let it be X. So the idea is always simple. You always have the 2 elements, the first one from your balanced equation, and then the unknowns. That's this. At this point, what next? Cross multiply. So I'll now cross multiply. So I have X times 1. So X times 1 is equal to this times this. 3 times 300. So I have that X is equal to 900. Check. We said X represents what there? Number of moles of hydrogen. So therefore, X is 900. So therefore, 900 moles of hydrogen, H2, is required to react with 300 moles of nitrogen. It is this simple, please. In all your this thing there, they'll give you 2. Pick out those 2. The first line of equation will be from the balanced reaction. The second one now will now be from the question. They said how many of hydrogen will react with 300 of this? So cross multiply and get X. It's simple. All right. Let's look at something much more complex. The first one is number of moles of reactants and products. They can still ask you how many moles of ammonia can be formed from 20 moles of nitrogen. In that case, it becomes nitrogen N2 and ammonia, NH3. First of all, get their molar balance. 1 and 2. So 1 and 2. So if they say how many moles of nitrogen, X, will be needed to produce 500 moles of ammonia, 500. So it's easy. It's easy. That's one. Number two, observe. In the question, they said how many moles of hydrogen is needed to react with 300 of nitrogen. So it's like saying in my question, they mentioned hydrogen first before nitrogen. But in my solving, observe, I wrote nitrogen before hydrogen. Why? I am following the sequence of the equation. So although they mentioned hydrogen before nitrogen, I wrote like this, just so I can follow the equation. But what if you choose to swap it? What if you write H2 and N2? Is it wrong? No. But then it's not that proper. It's better you follow the sequence of. So even if they mention hydrogen before nitrogen, for the fact that in my equation, this one comes first, it's advisable this one first before this. Number two, please. That's number one. Number two. Number two, mass. Number two, calculation based on chemical equation. Number two, mass of reactants and products. Number two, mass of reactants and products. You can continue in a given chemical reaction if you want to, or chemical equation. Mass of reactants and products in a given chemical equation. Take this down, please. What mass of oxygen is required to react completely? What mass of oxygen is required to react completely with 1.20 mole of methane? All right, so my question, we said methane. Methane is what there? CH4 combined with oxygen, O2, to give you carbon dioxide, CO2, and water, H2O. Are we still going to balance? Yeah? So carbon 1, balance. Hydrogen 4, I'll have to add 2 here. 2 and 2, 4, okay? Oxygen 2 here. Oxygen here. This is 2 plus 2. This is 2 here. 2 times 1, 2. So 2 here plus 2 here, 4. This one is 2. I'll add 2 here to make it 4. I now have a balanced chemical equation. Please check. Carbon is 1, 1. Hydrogen is 4. 2 times 2, 4. Oxygen is 2 times 2, 4. This is 2. 2 times 1, 2. So 2 plus 2, 4. It's a balanced chemical equation. Next task, molar ratio. I've said molar ratio is as easy as whole number coefficient. Here is 1, is 2, here is 2, is 2, here is 1, is to 2. My molar ratio is 1, is to 2, is to 1. That's my task. Next up, I said check. For every question, they will narrow your attention to two particular, perhaps one reactant or one product. Please check. In your question, what and what was considered? What mass of oxygen? So oxygen number 1 is required to react completely with what? 1.20 mole of methane. So oxygen and methane are my two focus. All right. So your statement, please. From the balance equation of the reaction, 1 mole of methane will react with 2 moles of oxygen. You can see here. From the balance equation of the reaction, you can write it down. 1 mole of methane is required to react with 2 moles of oxygen. Let the number of moles of oxygen required to react with 1.2 moles of methane be X. Let the number of moles of oxygen required to react with 1.2 moles of methane be X. Hence, of course, hence we'll have this one first, methane, CH4, oxygen, O2. Okay? This is 1 and 2. Notice that when I'm writing these ones here, I don't put this one. So I didn't write 3H2. No, just H2. Leave out the 3. This 3 comes here. So in the same vein, I'm having 1 and 2. We said number of moles of oxygen should be X. So X of this becomes 1.2 moles of methane. I have this. Of course, find X, cross multiply this and this. X times 1 is equal to this times this. 2 times 1.2. So X is equal to 2.4 moles of oxygen. Now check your question. It didn't ask you for how many moles of oxygen. Check. It asked you for what there? Mass. Mass. I have mole of oxygen. Can I find mass? Yes. How? Recall that we said that what there? Mole is equal to what? Mass. So mass of O2 all over. I'm writing this as mm because of space. In yours, write molar mass. So molar mass of oxygen. So mole of oxygen is equal to the mass of oxygen all over molar mass. Please, this is molar mass. Write in full. I'm trying to save up space. All right. What do we have? We already have the mole of oxygen, which we've calculated as what? 2.4 mole. No molar mass, please. Yeah, 2.4 mole. All right, so I'm having 2.4 mole of oxygen here. I have this. I'm about to find mass. Of course, first of all, I have to find what there? Molar mass. Let me get this value. Molar mass of oxygen, O2, will be equal to, for oxygen, what's the atomic mass? 16 times, how many atoms there? Times 2 atoms. Please, 16 is the atomic mass of oxygen. It's a constant. Please. 16 is the atomic mass of oxygen. It's a constant. So that's equal to what there? 32 gram per mole. If I've gotten molar mass and I've gotten mole, I can now find mass. Of course, from here, we know that mole is equal to mass all over molar mass. So look up, please. If I'm to get mass, it becomes mass times 1. That gives you mass. So hence, the mass of oxygen, O2, will be equal to the mole of oxygen. So mole of oxygen, this one times this one, times molar mass of oxygen. So hence, mass of oxygen is equal to, mole of oxygen is this one here, which we got from here, 2.4 times molar mass of oxygen. We've calculated this as what? 32. Please multiply this. What do I have? 0.88 what? Mass here is in gram. So please see the difference. These two are similar. Difference is that for this one, I'll find mole and stop. They ask me for mole, so find mole and stop. For this one here, they ask you for mass, not mole. So after doing the same thing and getting the mole, you still have to now find what there? Mass, by using this formula. So mass is just simply mole, which is this, times molar mass, which we've gotten this, and that. So there's no big deal. No big deal. So mass equal to mole times molar mass, please. Any questions, please? So I said, example 2, I said, what mass of oxygen is required to react completely with 24.0 gram of methane? Of course, the same equation of reaction, that methane, CH4, combines with oxygen, O2, to give you carbon dioxide, CO2, and water, H2O. Okay, balance up. We had 2 here, and we had 2 here. Molar ratio was 1:2:1:2. Next up, pick out the 2 important things there. They said what mass of oxygen, so number 1, oxygen, is required to react completely with 24.0 gram of methane. So oxygen and methane are the 2 important things there. So look up please. My first thing is this. I'm given methane, CH4, and oxygen, O2. From my balance equation, this one here is 1 and this is 2. Now, observe something. In this case, it said, what mass of oxygen? So I'm going to find mass of oxygen, okay, is required to react completely with, now observe, they gave you what there? 24.01 there, gram, not mole. Usually in our solvings, we need mole. Check our previous example there, they gave us mole for this, 1.20 mole. But in this case, they give us what now? Mass, no longer mole. So what's the task? Convert that mass to what there? Mole. That's the task. Convert that 24 gram, which is mass, convert it to mole first. That's the first task. All right, so my first task will be, depends on how you want to start. So let's start properly. From the balance equation, okay, hold on. Start it this way. Now we want to convert, what's that? 24.0 gram of methane from mass to mole. So take that, please. Converting 24.0 gram of methane, CH4, to mole. What do we know? We know that mole is equal to mass all over molar mass. So look up, please. If I have mass of methane, all I have to do is to first of all get what there? Molar mass of methane. So I can get mole. So my task would be the molar mass of methane, the molar mass of CH4 is, please, for CH4, what's the molar mass? For carbon, how many there? 12 plus hydrogen, 1 times 4, please. Atomic mass of carbon is 12. Hydrogen is 1 times, I have 4 hydrogen. So that's equal to 12 plus 4. That's equal to what there? 16 gram per mole. I'm calculating molar mass measured in gram per mole. So therefore, I can now find the mole of CH4, which is equal to, we said, mass of CH4, which is this one here, 24, all over molar mass of CH4, which is what? 16. All right. So what's the mole there? Sorry. 4 point what? That's equal to 1.5 what there? Mole. So I have 1.5 mole. So it's a bit tricky, but please try to listen and get it. Know why I converted in this case. Because I'm supposed to work with mole, not masses. Instead of them to give me mass, give me mole. Instead of to give me mole, they give me mass. To convert the mass to mole first. All right. So if you're here, let's proceed. Let the number of moles we work with, this is called molar ratio. Let the number of moles of oxygen. Let the number of moles of oxygen that will react with this one here now. What we've not successfully converted the mass from here to mole. So we can now say this. Let the number of moles of oxygen that will react with 1.5 moles of methane be X. Let the number of moles of oxygen that will react with 1.5 moles of methane be X. Hence, this one first, methane, CH4, oxygen, O2. First of all, molar ratio from balance equation 1 and 2. So 1, 2. Next up, moles as given. I wasn't given mole, I was given mass. I converted the mass to mole and I had this. So hence 1.5 of the methane will be equal to X. So let's get X. Alright, so simply X times 1, which is X, is equal to 2 times 1.5. So X is equal to what there? 3 moles of oxygen. Please check your question. Will we ask you to find number of moles or number of mass? Mass. So we know to do that. Convert this to what there? Mass. This is mole. Check. Your question didn't say we should find the number of moles of oxygen. It said mass of oxygen. I have gotten moles of oxygen. Next up, let me get mass of oxygen. How? We know fully well that mole of oxygen is equal to mass of oxygen all over molar mass of oxygen, such that if I cross multiply this and this, the mass of oxygen is equal to this times this mole of oxygen times this one here, molar mass of oxygen. So my answer is equal to, that means mass of oxygen is equal to mole of oxygen, that's this, 3 times molar mass of oxygen. We've not calculated before. Okay, we've not calculated here, but we know the answer, B. From my previous example, what's the answer? 30? 32. So please remember how we got 32. Oh, please go and check. We calculated this one here. For oxygen, 32. Yes. That was 16 times 2. Alright. So what's my answer here? 96 grams, Abby? Of what there? Alright, so that's how you solve this question. So just see how we play with mole and mass. That's the thing there. Right? Know how we play with mole and mass. That's the thing there. Alright. Alright, so you can try this at home. Just try this. Calculate the mass of carbon dioxide CO2 in grams that can be produced by bearing 6.0 moles of methane CH4 in excess oxygen. So you solve that question and leave your answer in the comment section.